Okay, this particular problem is written up in your notes in Canvas. So what I'm going to do is I'm going to do the video of this from scratch, and then you should be able to come back and read through this now and it be clear. So let me scroll down and I'm going to recreate the problem. So I want to solve this equation. Sine of 2 theta equals a half. Okay. So we want sine of 2 theta equals a half. And we want to solve this for when theta is contained in the interval from 0 to 2 pi. Okay. Now we should know by this point in the course that sine of pi over 6 is equal to a half. We should know that. Okay. So one solution, also pi over 6 is in quadrant 1. But we have 4 quadrants, and in 2 of them, sine are always positive. So there's another solution to this. And sine is positive in quadrant 1 and in quadrant 2. So there's another solution in quadrant 2, and its reference angle is pi over 6. So if I look at quadrant 2, and I have an angle in quadrant 2, and its reference angle is pi over 6, then if I go all the way around, that's the flat angle, which is pi. So I know this angle in quadrant 2 that I've drawn is 5 pi over 6. And sine of 5 pi over 6 is always going to be plus or minus the sine of its reference angle. But in quadrant 2, sine is positive. And so we get the positive one here, and the reference angle is pi over 6. And sine of pi over 6 is a half. So we have 2 solutions to this. Well, we know that sine of pi over 6 is equal to a half by the chart, or by common knowledge by now. And we also have that sine of 5 pi over 6 is equal to a half. Okay. And now we have to find out what theta is. And we have 2 theta inside here. So here we can put 2 theta is equal to pi over 6. But we will also have any multiple of 2 pi added on to pi over 6, because there's infinitely many angles that have their sine equal to a half. So if sine of pi over 6 is equal to a half, then sine of pi over 6 plus 2 pi, whatever that angle is, which will be 13 pi over 6 is also a half. So any multiple of 2 pi, positive or negative. So k is an integer. And same thing here. What's inside these parentheses? I can put that equal to it. So in both cases, k is an integer. Now, our answers must be inside here. Okay, and I have to solve for theta. So let's divide everything by 2. Because if I divide by 2, I'm going to get theta. But if I divide by 2 to get theta here, I have to divide everything by 2. Okay. And so I'm going to end up with theta equals, and pi over 6 divided by 2, that's the same as pi over 6 times a half. So this gives me pi over over 12. Now here the 2's cancel. Okay, and I'm going to have 5 pi over 12. And again, the 2's will cancel. Now I contend that if k is a negative 1, it's not going to put us, we're going to be outside of this boundary. And remember, the boundary is 0 to 2 pi. So if I think of the number line and of where 0 and 2 pi are, I only want things that are going to be inside there. I'm allowed to have 0. Don't want that end bit, but everything in between. Okay. So if I start with k is equal to negative 1, I'll do it on the next line. Then this becomes pi over 12 minus pi, which is minus 12 pi over 12, which is minus 11 pi over 12. And that's over here. And so that's not in our interval. And so I reject that. Okay. Now, if k is equal to 0, of course I get theta equals pi over 12. And pi over 12 is somewhere in here, and it's inside my interval, and it's allowed. So my solution set, pi over 12, is going to work. Okay. Now, let's keep going. What happens if k is equal to 1? Well, if I come back up here, I get theta is equal to pi over 12 plus pi, 1 times pi, and I'd rewrite pi as 12 pi over 12. So I can put these together, and I get 13 pi over 12. And 13 pi over 12 is less than 2 pi, because 2 pi is the same as 24 pi over 12. So 13 pi over 12 lives in here. And so it's definitely counted. It's inside my restriction. And now if k is equal to 2, this will become pi over 12 plus 2 pi. And I am outside of the restriction because pi over 12 plus 2 pi is beyond 2 pi. And so that's not allowed. That's not going to be inside our restricted. And then once k gets higher than 2, it's going to be outside this red zone. So I'm done with this one. I have found all the ones that solve it where we're in our restriction. We have pi over 12 and 13 pi over 12. Then I look at this one that I've written up. And again, if k is negative 1, then that's going to give me 5 pi over 12 minus pi, which I would write as minus 12 pi over 12. And that's going to give me minus 7 pi over 12. And that's outside of this interval. So that's not going to be allowed. And if k is equal to 0, I just get the 5 pi over 12, which is inside our interval. So that goes down over here. And what happens if k is equal to 1? If k is equal to 1, I'm going to get theta is equal to 5 pi over 12 plus pi, which is 5 pi over 12 plus 12 pi over 12, which will give me 17 pi over 12. And that is less than 2 pi, because 2 pi is the same as 24 pi over 12. And so 17 pi over 12 is less than 2 pi, and it's inside my interval. Okay, and once I get to k is equal to 2, then I'm outside the interval, because I'll have 5 pi over 12 plus 2 pi, and it's outside of our interval. So inside that restriction there gives us these 4 values. Okay, and so if we come back here, it might make more sense now when we see this. I might try and get it a little bit bigger. Okay. of what they're trying to do there. So we got pi over 6 and 5 pi over 6 as the two angles that worked in quadrant 1 and quadrant 2. We wrote them in their infinite form when we added a plus 2 k pi, and then we divided everything by 2, and then we tried different k values. We started with -1, and what we got was not inside our allowable interval. So all those I circled in red were not allowed inside the interval. And the only ones that worked, of course, the k equals 0 would work, because those were the original ones that we found. But we also found some more when k was equal to 1. So we ended up finding 4 altogether. Okay. So hopefully that makes this example 4 a little bit clearer. And that ends this video.